Swayam Prabha. Digital India. Educated India.
Right? So AC voltage is at this point, and I'm going to have the load voltage like this. Right. So let me call them as D1, D2, and I'm going to call this as D3, D4. So I'm sure you guys know the basic way of conduction. So let me call these terminals also A and B. So it is going to start from VAC is A during positive half cycle. Right? I'm going to have this as plus and this as minus. So I'm going to have from VAC is A point. From that it is going to go towards D1. Then it will go through the load. Let me call this as maybe P and Q. So Q, then to P, then to D4, and then back to VAC B point. Right? This is during positive half cycle. During negative half cycle, you need D3 and D4. This is during positive half cycle when I'm having plus here. So diode D1 is connected to the plus terminal of this. So this is also plus, right? And similarly, this is minus. Yeah, but you need them for the negative half cycle. We have talked about this only for one half cycle. So you need them for the negative half cycle, right? So during the negative half cycle, right, I am going to have plus here and minus here. This is during negative half cycle. So obviously, if this is plus, I am going to have this portion as plus. So if this is plus, I am going to have D2 forward bias. So D2 and D3 will be forward biased. Here of course D1 and D4 will be forward biased. Right? So you can definitely write the path again. It will go through D2, Q, P, and then it will return through D3 and then go back to the negative, which is A is now negative and B is positive in the AC supply. So you are going to have the other way round. So we will have, let me write again the path. VAC is B point, D2, Q, P, and from there it will go to D3 and then VAC is A point. This is the way it is going to conduct. Right? So if I am looking at the waveform, we'll have to look at many things. One is, this is the I load, and I'm going to look at I source or IAC, whatever. I source and I load. And of course output voltages. We'll see that also. Right? So this is my AC voltage. And when I am assuming that the two diodes are having hardly any drop. Please note two diodes are conducting in this case, which is definitely going to give me more drop than the previous center tapped case. Center tapped case will not have this much of drop, whereas here I will have 2 times 0.7 volts, definitely. Right? So I am going to have probably during positive half cycle, I will have the voltage as it is being reproduced. And during negative half cycle, again the same voltage being reproduced, but in the opposite direction. So, red color, whatever I have drawn, will be the voltage of the load. And blue color is VAC. Right? If it is pure resistance load, the voltage waveform and the current waveform should be exactly matching with each other, because of which I will have the current waveform somewhat like this. I am showing as though there is a very large resistance, so small current, right? Anyway, so it is a sinusoidal current waveform that I am going to get, which is whatever is the V load divided by R. So I am going to have this as V load divided by R equal to I, provided it is a pure resistance load. Purely resistance load, I will have something like this, right? Let me look at what is I source. Whenever D1 is conducting, the current is in this direction. Whereas whenever D2 is conducting, the current is in the opposite direction. So I am going to have the current flowing this way whenever D2 is conducting. Whereas this direction will be whenever D1 is conducting. Please note that the source current reverses its direction depending upon whether it is positive half cycle or negative half cycle. So, if I try to draw what is the kind of source current I am having, I will have the source current to be sinusoidal, which is something like this. So, I will have an AC current coming into picture in the source, which is good for me if I am using a transformer. It will not get saturated because fluxing and defluxing keeps on happening because of the currents that I am having in the positive half cycle as well as negative half cycle. So I am going to have basically AC current flowing in the case of full bridge rectifier. Whenever I am considering a diode bridge rectifier, there will be AC current flowing. So this is AC, so no saturation of input side transformer. Right? I am sure you can derive the expression for voltage. You have to essentially say V average on the DC side or load side will be equal to Vm sin omega t integrated over 0 to pi averaged over pi. It is repeating itself, right? D omega t. This will be definitely twice the value what we got. So 2 Vm by pi. Right? Okay? What happens when I replace this resistance by an RL load? Right? So let us say I am going to have again a full bridge rectifier uncontrolled, and I am going to have RL load. Obviously, I am going to have D1, D4 conducting during positive half cycle, and I am going to have D2 and D3 conducting during negative half cycle. No doubt. Right? Let us say I am just starting out. I have just turned on the power supply and then I am going to have multiple cycles like this for the input side voltage. Circuit is dead, so the current will start from 0, no doubt. The initial condition will be 0. So maybe the current would start flowing. It had reached some peak somewhere and then it would start declining. Agreed. But when the negative half cycle starts, I'm going to have again D2 and D3 taking over, right? When the negative half cycle starts, I will have D2 and D3 taking over. Because D2 and D3 are taking over, previously in the half wave rectifier, we saw that in the negative half cycle, VAC will start opposing the flow of current. Whereas here, that will not exist. That opposition will not exist. Because the moment the negative half cycle starts, D2 and D3 are going to jump into conduction. Once they jump into conduction, again I'm going to get a positive and negative voltage like this. Whether I like it or not, still I will have positive and negative coming up like this. And because positive and negative come up like this, in all probability, I may have the current again increasing. It depends definitely upon, because I have to write the equation somewhat like this. VAC equal to Ri plus LdI by dt. Right? This is what we wrote. But this is true when I am talking about D1 and D4 conducting. If D2 and D3 are conducting, I have to write minus VAC. I hope you understand, because I am having opposite sides connected now. If I say Vm sin omega t, that was connected directly. Vm sin omega t was directly connected to the load when D1 and D4 were conducting. Whereas Vm sin omega t, when it became beyond pi, the reverse of that is connected to the load. So I should write that as minus Vm sin omega t being connected to the load. That's what I'm trying to write this as, minus VAC equal to Ri plus Ldi by dt. That will be when D2 and D3 are conducting. Right? So at this point, maybe the current would come down for some more duration depending upon this value, whether it is good enough to dominate over IR. But if IR happens to be still higher than VAC, LdI by dt has to pitch in. You get my point? I am having IR value, let us say, at 20 volts. VAC is just starting out from 0 volts and it is going towards 10, 20 and so on. If it happens to be only 10 volts, it will not be able to fill up really the requirement of the resistance. So it has to borrow from the inductance. So whenever it is borrowing from the inductance, the current will still come down. The moment my supply voltage again reaches 20 volts or 25 volts, now the supply voltage is strong enough to take care of the resistance drop. So it can give whatever it is available with itself, it can give it to inductance. The moment it starts giving into inductance, the current will start rising. So I would see that the current probably falls a little bit more and after that it will start rising. Again it will reach a peak and then it will fall and maybe again it will start rising and so on and so forth. Please note the way I have drawn. Initially it started from 0. In the next half cycle, it is not starting from 0. It is starting from slightly higher value. And in the next half cycle, it start from further higher value. Eventually, it will reach a steady state where the beginning of every half cycle, it will be at a particular value. That is when we call it a steady state. There is no steady state otherwise like DC. You're not going to have a steady value here. No way. Rather than that, whatever is the initial point I'm getting at the beginning of the half cycle, is it becoming a constant eventually? The maximum value and the minimum values, are they becoming constants eventually? Once they become constant, we call it as the steady state has been achieved. Right? Don't please confuse with the DC, because you cannot see a steady DC here. No way. You would always see an oscillatory DC current. So, this is the way the current is going to increase. If I have very, very high inductance, the oscillation that happens between maximum and minimum will become smaller and smaller. That's why we call inductance as a current ripple filter. Inductance will always even out, any increase or decrease that happens in the current. That's why inductance work as a current filter. Just like how capacitance acts like a voltage filter. Because it gets charged and retains it. Right? So you will always have inductance, higher inductance, always producing a current where the ripple or the difference between maximum and minimum is kind of brought down. So it evens out any oscillation in the current. So if I say finally in the steady state, I may see something like this. If this is my supply voltage, right? So this is the transient current. This is a transient DC current. Right? So if I say that this is my voltage waveform, I'm going to see that maybe the current is starting from certain value, it rises and it falls, again rises and then it falls, again rises and it falls, and so on. So all the maximums will be at the same value. If I have not drawn it that way, it is wrong, but all the maximums have to be at the same value. This is I max or small I max. Similarly, this will be small I minimum. All the minimum current and maximum currents have to be at the same value. Right? So, if I try to draw the supply current now, please note that 0 to pi D1 and D4 will conduct. Yeah. Here it is starting from 0. Once it reaches steady state, please note this is at 0. The next one is not at 0. The next one is even higher. It is still going through transient. So it started from 0 and slowly it is going towards higher and higher value until reaches steady state where the minimum and maximum become within a certain range. They don't really change anymore. The minimum value becomes like a constant, maximum value becomes like a constant. Same thing is true here. Right? So, whenever D1 and D4 are conducting, I will have probably positive half cycle current. And whenever I'm going to have, I told you that it can still decrease. So, that small decrease I am showing here. The current could decrease because inductance might have to pitch in. So, this is the way it is going to be. I would earnestly request you guys to do one thing. There is a software called PSIM, okay, from PowerSim Incorporated. Student version is definitely available. Download it, and I am sure some of your seniors will have cracked version. You can definitely take it. Try to do some small simulations to understand the waveform. It's very easy to learn.